Hi, and here we are. Today we're going to talk about all things DNS. Yay!
Yay!
Right?
Welcome to PDQ Live, everybody.
Welcome. So we've done a bunch of webcasts on DNS. Brig, you've been the star of those webcasts.
Oh.
Thank you. But today we're going to talk about DNS and security.
Yes, indeed.
Who are our guests? Let's tell who they are and give their credentials.
Okay.
Go
Rachel is our first guest. Rachel, you are our SOC analyst. Yes?
Senior. Don't forget senior.
Senior SOC analyst.
Yes,
Thank
that's
you.
important.
Josh is, I'm going to call Josh our IT director, but that's not what he's called.
I'm here and I do things.
Yeah, he does.
He's in charge of wrangling me.
Yeah, he does stuff.
And the
then
internet and
Brig.
all of the things technology.
Brig is the DNS wizard, a.k.a. vice president, and a bunch of other stuff, right?
Things.
Things.
Titles. Yeah.
Things.
Yep.
Yeah.
Vice President of DNS.
Jay called it out. He's absolutely right. I don't actually do anything.
Yeah.
Yep.
Yeah, you play games.
Yeah.
You play video games.
He corrals IT.
Yeah.
Yeah.
So over
Exactly.
here, we don't do anything. Over there, all the things are done.
Yeah.
Yes.
We're going to do everything on this side,
Debatable.
right? Yeah. Okay. So, Brig, you've covered this so many times in prior webcasts, but can you just start us out with some basics of DNS, please?
Yeah.
Just break it down for us, because who understands it, really?
Yeah,
Except
and
for
we-
you.
Well, I mean, I think a lot of people understand it appropriately, but strangely enough, the analogy of the phone book is what's commonly used. Not my favorite analogy to describe DNS. My favorite analogy is really kind of a post office. So, for instance, like, so when you send a letter to somebody, say like you're sending a letter to Sid in Connecticut or something, what you do is you send that off, and the post office goes like, oh, I'm looking at the zip code. And the zip code has a set number of numbers, and the first number basically indicates the region of where that's at. So, for instance, like I think there's like 7 or 8 different regions for this. It goes to that region. It goes to the regional or the office of that. For us, it's Salt Lake City. So, if we were receiving something from like back east, it would come to the Salt Lake City office, and then the Salt Lake City office goes like, oh, okay. So there's the 8, and then there's the 4. Well, okay. Well, I know that the 4 is in this particular region of where I'm at, and then so I'll send it to that post office. That post office goes like, oh, well, and I know that it's the 101 or the 103 or et cetera, and it knows the basic neighborhood of where that goes. So it's routed to the local post office, and then that post office delivers it because then now it has the address, so the specific address. So DNS works similarly. So you've got your root servers, which are really just basically pointers to the TLD. So at the end of every single like address that you put into on the internet or anything like google.com, it's actually google.com period. Period is the root server. And so you just don't put it in there because it's not necessary because there's nothing greater than root. So you've got the dot, which is the root server, and then that points to your TLD, which is like your .com, your .edu, your .org, and all of the later ones. And then those are like, yeah, I got that one. And then it knows of the other name servers that have like additional information for those particular domains. And so then you finally get down to an authoritative server. So it's a hierarchical system. So it's incredibly resilient, just like a post office is. But yeah, that's DNS in kind of a very brief, very small nutshell.
How many root servers?
I think there are 13.
How? That is mind-boggling to me.
Well, then I think there's 3 of them that are maintained by VeriSign, and I think VeriSign actually those are like the root servers. Yeah, so they're like the authoritative servers for the internet. But again, there's not a lot of traffic to those servers because they're just really just pointers to like, if you put something in, like if you put in a blah 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 blah.com, it'll go sometimes to a root server, especially if it's an unknown domain, and then it will go. The root server will just go like, oh, it's a .com, and immediately say like, this is the server for that.
Because it knows where to go.
Yeah, but typically, most requests don't ever get to a root server. Yeah. So, yeah, and it's not like they have these huge lists of all of the addresses. That is crazy. That used to be the case. They used to have a host.txt file back in the 80s, and then was just they would update it. But yeah, that's
Now,
not
do you
the case
think DNS is secure?
well,
Loaded question. I know.
yeah,
I know.
Like no,
Yeah.
and yes. It depends.
Is it a flawed system, would you say?
No, it is definitely not a flawed system, but it was certainly created in a happier, more naive time.
Okay.
Yeah.
As most things on the internet.
Yeah. Like there was a recognition back in the early 90s that they really needed to do some security upgrades to DNS. And so I think they started doing DNSSEC in 93 and then finally published it in 2005. So, I mean, there was a clearly people anticipated a need for that.
And that's what is that, like a security add-on?
Yeah. Like it's just, security and encryption add-on to DNS.
But it hasn't been widely adapted yet. True?
Yeah. It has and hasn't. Yeah.
What's the problem?
It's difficult. It's hard to understand. I think Josh said earlier that big AI infrastructure is not an easy thing. Like, there's more. It's not at all pretty. There's nothing amazing about it. It's not very fun.
Yeah. And it's only effective if every resolver along the way uses it. If you have something in the middle anywhere along the way, then you're back to just regular unencrypted DNS traffic.
So is that chain of trust? Like it has to start at the top and go down? So does it even matter if someone in the middle does it? I mean, does it help?
I mean, you have to have adoption. Like it's only going to help if everything does it, and you're only going to get there if more people adopt it.
What do you think is going to be, what's going to tip that scale? Who's going to be the person that adopts it that's going to make everybody follow suit, do you think? Or is there going to be any one movement?
Probably an attack. Yeah, it's usually, I don't know. Josh may have different opinions on this one, but typically you secure your stuff as a reaction to some kind of threat.
Yeah. I think it's important to differentiate between like a corporate DNS infrastructure using DNSSEC and wide open internet using DNSSEC, right? Like if I'm going to ask a residential internet subscriber to have their edge device, their DNS device, whatever that is, perform DNSSEC,
like who cares?
that's going to be hard. That's like we can barely have people set up their own Wi-Fi.
Yeah, unless it's default on that device already ready to go.
And so you get this device, and then you've got all of these keys that then have expiration dates. Oh, and then you renew it. And so, sure, theoretically, you could have a service that's doing it like a Let's Encrypt or something like that. But it's hard, and trying to sell that service to someone, it's because it has an increased cost for a consumer device.
Yeah.
It's going to be really hard.
So, okay, I researched it a little bit. So it's domain name system security extension. So you said a security extension. So it's using digital signatures based on public key cryptography. I can't even say it. So it has 2 additional security features as opposed to traditional DNS, and they are you ready? Data origin authentication. So what does that actually mean?
Oh, basically it just means that you're authenticating that, if I understand correctly, that the origin of the request or what the information that you're getting back is authoritative.
Like that's saying that it really came from that zone.
Yeah, it really came from that zone. And then then there's the opposite, which is the like the unauthenticated or the thing that doesn't exist, like a non-existent domain, an index domain. So there's just the opposite of that, where it's basically saying like, okay, well, you put in like example with 2 E's or something like that .com. It's going to return example.com because it's like, and so you know that example does not exist.
Okay.
Yeah.
And the second was data integrity protection, so not modified in transit.
Yep.
So, okay, I'm guessing this is going to come up as we discuss our threats. So now we kind of understand a little bit what it is and why it's kind of hard to adopt. So, okay, Rachel, you ready? Tell us about why we should be scared of these DNS security threats. So first one we're going to talk about is what DNS cache poisoning or spoofing.
Yes.
What is this?
Yes, my favorite.
Well,
your favorite. Rick.
Oh no, I was just going to say that poisoning and spoofing are different. Spoofing is the result. Poisoning is the actual act.
Yes.
Okay, perfect. Go ahead. Expand.
Well, okay, so DNS cache poisoning, we should start with, is when an attacker gets a hold of your host file and modifies it. So, for example, you try to go to google.com and your DNS cache that you have on your machine goes and looks at the host file and it goes, oh, okay, yeah, I know where to go. And it takes you to boogle.com where, some baddie is going to, hopefully try to ensnare you. And it could look just like google.com. And then it will do some kind of malicious payload or try to get you to download something or click on a link, that sort of thing. So it's an attacker's way of transferring you, rerouting you to a bad site.
Okay.
Do you want to expound on that at all? And that's the spoofing part, right? Is you've poisoned it and now you're spoofing, right? Okay. Because when a DNS request goes out, it's looking for an IP address. It's trying to translate that domain name to an IP address. So if you interrupt that and put in your own IP address, you're going to end up somewhere where you didn't intend to go.
So the host file is compromised. That's the essential
Yes.
description.
And it might be helpful to just take a quick recap on name resolution order.
Okay.
Right. So if I'm a client device and I want to go to Google, I'm not going to hit a DNS server with that request every time, especially if I've already been there. I'm gonna cache that.
Yeah.
Otherwise, I'm going to overwhelm this. So I'm going to look first to like, is it me? Am I looking for myself? Localhost? No. And then I have this thing called the host file, which is really just that carryover from times past.
Yeah.
Right. It still exists, but it's a carryover. And then I look at my cache. And then, only then, if I don't have it anywhere else, then I'll go to a DNS server.
Yeah. So local first. Yeah.
Yeah, so which is why this attack is really effective because you don't ever even get the traffic out to a DNS server because it's in the host file is right there.
Yeah.
It's also very difficult to do now. So that's why I think the last big major attack was back in 2018, and that was some crypto website that then there was $150,000 that was stolen in crypto. But it's hard to do because you need to know that the unique ID of that particular request, of the cache request that's going out. And so there have been some security modifications that have been done to that. So you need to know the 16-bit number. You need to know like the requesting server itself. And so you need to, and those are kind of guesses. You don't really get to know you can get it, intercept it, but it's hard. So it's not a like we don't need to worry about it every day typically.
Oh, good.
Yeah.
Well, thank God.
It isn't nearly as common as it used to be, for sure.
Okay, so solutions. How do we prevent this?
I mean, I think the biggest thing is to have some kind of endpoint detection to detect that the host file is getting modified.
Okay.
And also constant vigilance of, are you using HTTPS? Is this, you're looking for that little green bar in the URL or whatever to make sure that you are where you think you were going.
Okay.
Right. That's not as easily spoofed. Right. And I do see a question about using PDQ inventory. I imagine you could probably have some kind of PowerShell script that watches that file for modifications. I would imagine.
Yeah.
Absolutely. So if you use a PowerShell scanner, if you copied in what was in a host file and used that and assigned it to a variable and did a comparison to importing on the remote machine, it would come back if there's anything changed in it. It wouldn't tell you what was changed. So if you have legitimate ones in there, you need to update your variable, but it is possible.
Yeah, and there's rarely times when you need to change that host file. I mean, that's very, very rare. So I think any good EDR endpoint detection will notify you immediately. Yeah, the host file should be empty 99% of the time for sure.
Well, not empty, just
Localhost 20.127.0.0.1.
Yes.
And then
yes.
an IPv6. Yep.
DNSSEC, based on what we said, would prevent this, yes? Because it detects if it's modified in transit.
Yep.
Yeah.
Yeah.
Yeah, DNSSEC would help as well. The comment about firewalls, yes, packet sniffing would help because it would notice that irregular traffic, be able to detect that.
You can also do a file scanner on the host file and look at the size, check the size out on that and see if there are any differences.
File integrity.
Modified date.
Yep.
Yeah.
And then and you can also just typical security practices, just look for anomalous behaviors. So for instance, like a lot of DNS traffic is going to be, why are we doing that? Or a lot of or a decrease or an increase in web traffic, especially on a local system, because this is a local system issue. It's not a widespread, it's
not networking equipment.
Yeah.
We're talking endpoint devices. And Windows Defender is a good example of an EDR that will detect it as, in my experience, as soon as that file gets changed, I know about it immediately.
Okay. All right, next one. We have DNS amplification. Tell us about that
Yes. This one is kind of a unique case. I can't imagine very many SMBs would have this issue.
It's got a cool name though.
Yes, it does. So this is a form of DDoS attack where you're exploiting open recursive DNS servers to basically just amplify that traffic because you can exploit the recursive ability of it to amplify your DNS packets and crash the server or,
Overwhelm.
overwhelm it.
Okay. So what are some remediations for this?
The classic blocking spoofed addresses. right? You can detect that somewhat easily. It's also pretty easy to spoof IP addresses, but it also, like, unless you have a really good reason to have a public DNS server, you're an ISP or MSSP or something like that, some kind of service provider, you really shouldn't have an open public DNS server. So if it's internal and it's not going to be public facing at all, then the recursive should be fine to be there. Okay. And then unless somebody gets into your network and starts doing that, but then you've got bigger problems other than DNS. That's just going to be a symptom of somebody already in your network. So definitely, if it's open, turn off the recursive if you have to have it open.
Okay. You guys want to add anything to that? Good with that?
No.
Okay, cool.
Yeah, I mean, it's a denial of service attack.
Yeah.
Let's throw a question in here too. We just got a new one. Says, if an attacker is in your environment, then would you need to detect modification of Windows DNS? Sharon P.
I mean, always really good to check.
Yeah.
Like,
Are we talking like endpoint?
yeah. Or are you talking like within the Windows Server environment itself? I mean, yeah. Well, detecting modification of Windows DNS is relatively difficult. Like I said, you can the files themselves. You can look at the zone files. So the zone files are located in Windows System 32 DNS, and they're actually like just text files, and they're written in this kind of C format. So you could periodically check those, but typically, and Rachel, this might be more your thing, is that I would suspect that it's just going to be like any sort of like attack surface. You're going to want to check all of your major systems like Active Directory, users, computers, DNS, everything like that.
Yeah, DNS, I would imagine, would just be a symptom of a larger attack.
Yeah.
And it's just, it's this idea in security of you can have this really hard shell on your attack surface, right? But if somebody gets in and all your gooey, soft insides aren't protected, then you're going to just get pwned immediately, right?
Yeah.
And so it's these layers of security. So your DNS server internally should be secured just as much as your attack surface is secured. So yeah, that's super important.
The bad news is, of course, that if you've already discovered an attacker, that attacker's probably been in there for a while.
Yes, Hopefully not too long.
Yeah, but it's probably been longer than really. Yeah.
Yeah, if you're noticing your internal DNS server is having odd traffic, then you're already in deep. Right.
Yep. As I think someone said, like, Marcel, shut down and clean up. Yep.
Yep. And then I see another question here about.
We can throw it up
he'll
there.
bring it up.
Okay, do it.
All right, here we go. What are your thoughts on Chrome's upcoming change, doing away with a secure lock icon in the URL bar and replacing it with some weird toggle icon? Craig M.
I have strong feelings about this.
Let's hear him.
So I used to work tech support for a certificate authority. And when Internet Explorer got rid of, they used to have big light up green when you had an EV certificate, right? Because and for everyone who doesn't know, you've got different levels of TLS certificates. You've got your DV, OV, and EV. Your DV is your domain validation, where literally all you have to do to get that certificate is prove that you own the domain. You have OV, which is the same thing, but additionally you have to prove some things about your organization, and it will list that then on the certificate. And then you've got EV, which is even more stuff that you have to prove and even more details on your certificate. So it used to be in the past that Internet Explorer, when you had that EV certificate with all that validation that you went through, it would just big green. You could feel pretty safe about going to that website. They went away with that. And when that happened, we got flooded with calls of, hey, I've got this EV certificate, but nobody's seeing the green bar. Why is that? And we had to go, well, it's not our fault. Nothing changed on our end. This is Internet Explorer. And this is a common problem with CAs, is browsers changing up things, right? Am I a big fan of the change? It depends. I mean, if they're going to make it big and noticeable and make it easier to tell that you're at, a good website that's been encrypted using a verified TLS certificate, then I'm all for it. But if it makes it even less noticeable and more difficult to verify that, not a huge fan.
I guess I agree mostly, except for just the green lock anymore is so easy to get. Like anyone with 5 minutes goes and can grab a Let's Encrypt cert, and it's valid HTTPS. It's valid TLS cert. So like I don't know the specifics about the toggle, but if it makes it look like, hey, this is just like a generic or wildcard, or you may not actually be where you think you are, then great.
Yeah, and that's the whole reason I brought up the big green bar in Internet Explorer, was because that was great.
Yeah.
Because it wasn't just a normal like Let's Encrypt domain whatever. Like it's important that any site you're going to is HTTPS, especially with DNS security. But unless there's some differentiator between that DV and even OV, then it's not super, super helpful.
Okay, let's move on. We got to get through our threats because you guys are freaking me out. I'm already nervous about all of this. Okay, DNS hijacking. Tell us about this one.
This one's another really good one. It's very similar, I think, to the DNS cache poisoning, where it is an endpoint attack, right? They're not going into that host file because that's kind of easy to detect. We know about that one. So instead what they're doing is they're changing your actual DNS settings. So, you go in and you're doing some troubleshooting and you maybe don't have a DHCP server or whatever. And so you're putting in a custom IP address in there and you set your DNS server, right? That's where they're going in and changing that DNS server to something that's malicious. That one's really hard to detect, I think, unless you're watching for those settings being changed.
Yep. I think like a common maybe attack with that would be that I would actually run a valid DNS server with proper forwarders.
Yeah.
And I would only put static entries if I wanted to capture your traffic for a very specific, like a spear phishing or like a very targeted attack, where like I'll change it on the endpoint of the victim's computer, and I'll still redirect them to Google, Instagram, wherever they're going, right? I'll just forward that like it's normal. But maybe they have like a company intranet site. That's the one that I'm going to grab, and I'm going to redirect to my malicious site.
Yeah.
But forward everything else.
You are terrifying. Okay, just terrifying.
I would also probably, you could also do banking sites as well, because you just have to make it look like it's the normal site.
So even harder to catch. All right, so how do we prevent this one?
Well, Marcel just gave the answer. You can create firewall rules. You can do all sorts of things to make sure that you're only using the DNS servers that you say. So if a user's endpoint is trying to go to some DNS server that you haven't said is the one that you want to use, then things are going to break.
Yeah, this is another one for DNSSEC internally, right? If when I go to get that result, if it's not what I'm expecting based off of that public cryptography, then all of a sudden I know it's invalid.
Yeah.
Yep.
Yeah, and I imagine there might be some things you can do, PowerShell, or domain policies or whatever to make sure that can't be changed. I imagine. I'm not super familiar with that. I don't know.
I think we're going to talk about that at the end, aren't we?
Yeah.
Okay.
Probably.
Okay.
But yeah, and always update.
Update is our friend. We love
Yes.
updates. Okay, let's try and get to tunneling, and then we're going to do best practices. So DNS tunneling, bypass security controls. Ooh, that sounds awful. Okay, what is that?
Yeah, I think all these are my favorite. Honestly, I keep wanting to say that. I think these are just such fascinating, just very niche attacks, right?
Okay, you're kind of a sick person, but go ahead. I like it. Go ahead.
I mean, there's you have these DNS packets, right? And they're usually pretty small. They're just doing simple requests. Well, attackers have found that they can actually add malicious payloads to these DNS packets and hide them in there. That way, when those DNS packets are going through, your firewall's like, oh, your DNS, you're fine, just keep going, right? And so then it will do, it will execute, I think that we've seen an example of PowerShell commands being hidden in there.
Executable ones.
Yeah.
That's terrifying. This one sounds the scariest to me. What do you guys think?
Well, I think it's fairly easy to detect now that we know that it's doable.
Okay.
Because what you would be looking for is these very weird DNS traffic patterns, right?
Because they're going to be big?
Yeah, these bigger files, because like I said, DNS packets are relatively small and very relatively simple, right? You kind of know what you're looking for when you're looking at DNS packets. But as soon as they start being really big and having way more information in them than they need, that's when you know that something's going a little wonky and wrong.
Okay. How else am I going to see them?
Well, the other one, this one's probably going to be combined with another attack, right? This is going to be combined with
malicious.
that DNS hijacking, because like when I'm making a request for example.com, I'm probably just looking for an A record. Like, right, I want the IP address to come back.
Okay.
But if I'm like a malicious DNS server, I'll give you the A record, but I'm also going to give you a text record, a TXT record that has way more information, and that's where I'm going to shove all of this executable stuff. But I mean, the packets are only so big. You only have so much in the buffer size. So I'm going to actually make you return lots of results very quickly in rapid succession for probably the same thing or just very similar, so that on that target device, I can compile larger strings of data.
Yeah, and we saw an attack. It was a fileless DNS query, and how it was done was it used a malicious Word document, and you had to enable the macros, and then the macros kicked off a PowerShell command that then caused that to be able to happen, right? So it's layered attacks. A lot of these are very layered attacks where they already have initial command and control. They've already taken control of your machine, and now they're doing something.
So I have interviewed an ethical hacker. I entered about it. His name is I.M. Jacoby that did this with PowerShell. And the biggest risk with that is since it's run within the DNS query, it's not running within the normal environment. So a lot of your security protocols don't prevent the script from running. I'm not sure if it impacts constrained language mode, which is your best security, but things like execution policy won't apply for that one. So once the PowerShell's in there, it's pretty hidden unless you're looking for that specifically.
Yeah, you've almost got to have like deep packet inspection, looking at like, wait, why is all of this coming in? And that's a whole other can of worms. And really only works in like a full tunneled VPN environment or 100% on-prem. Well, once you get users that are off on their own home Wi-Fi, oh, who knows?
Yeah.
Why are you guys so calm? This is terrifying.
Well, there are a lot of things that have to come into play for these. There are a lot of pieces that have to come together at the same time in order for this to work out. Like you actually have to have malicious software, in play here. So if you're relatively safe and you're got updating, you're patching, you've got some kind of like defender software, chances of this happening are slimmer. So, but never zero.
Yeah, it's that layered security, right?
Yeah.
You've got a lot of dominoes that have to fall before you get to this point.
Kelly, do you want to do questions before Brig and Josh talk us through best practices?
We've got one question in the queue if you want to take it, or do you want to wait till the end?
Do you want to do the best practices, you guys? So can you show us some good tips on how we could maybe prevent these from happening to us in our DNS?
Sure.
Yeah, you're driving.
I'm driving? All right, you got to tell me where to click then.
All right. Well, we can do, the first thing is just setting up DNSSEC.
Okay.
Yes, let's do it. Everyone. It starts with one person, Josh. Let's do it.
He's getting serious.
It's one person. All right, where do we do this then, Brig?
I think we do this as the zone file.
The zone file?
Zone, zone, and then sign the zone. And then we can just walk through this, custom, the first result there is fine.
All right.
This is assuming, of course, you don't already have an existing like structure or anything like that. So this is just
Which
gonna be
we don't.
basic. We don't.
We don't.
Yeah, the next one, the DNS server, this is going to be this one.
Okay.
It's the DC. And then, this is the key signing key is authentication. Key signing keys signs itself. Reasons. That's to be clear, we should probably do a webcast on DNSSEC just on its own. So we're just kind of showing you here, just sort of like it's not super scary if you go in there.
Yeah, cryptography's hard.
Cryptography is hard.
No.
Yeah.
Okay.
And then you can use, you can generate a new signing key. And then, these default values are fine. 248 or 2048 that's excessive, but
That's big.
that's fine.
We can use pre-generated keys if we already have them.
If we already have them. Yeah.
Yeah.
And then, or we can just create one and then, okay.
There's our key signing key.
Yep. Now our zone signing key.
We're going to do the same thing again, right?
Yep. Yeah, default values are relatively decent here. Like there's nothing that's going to be, but
Ooh,
also
that key length is a little short though.
it's 1024.
That's a little short.
Yeah. Yeah.
Okay.
Yep.
This is a big wizard.
Yeah, it is. Yep.
All right.
Yep. And you
Getting
can
tired?
Yeah. I mean, and the default values are typically going to be fine on most of these.
Okay, we got polling parameters, so it's like time to live.
Yeah,
all
time to
kinds
live.
of stuff. Like all of these things are probably worth a little bit of reading before just running through the wizard.
Yeah.
Okay.
And I always like to do a shorter time to live. Just I think an hour is always pretty about the maximum that I like to put on basically any sort of record or any sort of security, just because that way you're more in control.
Yep. All right. I'm not going to turn this on.
Yep.
Mid webcast.
Nope. Yep.
Thank you.
Okay, break. I mean,
Everything goes dark and everything like that. Sorry.
Hey, no, we have
It
good.
wouldn't happen.
We have good caches. We're going to
Yeah,
be
we're
good for a
fine.
minute,
Yeah, we're
but
okay.
But next week.
there you go. Yeah.
Yep.
Next week when I've forgotten what I've done.
yeah, I mean, why not?
Yeah, and then the next thing that you can do is DNS over HTTPS, which is called DOH, which I really like, DOH. So, and then there's not really kind of an example to say to do this here, unless we may be able to do it here. I'm not sure if we're configured for this, but you do that. You can do that at the endpoint, and you can also set that up in group policy, so that you can just basically just do any sort of like DNS queries over HTTPS, and it's relatively simple to set up. We should probably cover that too, and its own separate as part of DNSSEC, because these are kind of there's sort of two related things. One's kind of an endpoint way of like securing your individual machines, and then the other one is of course making sure that your DNS queries, generally speaking, are encrypted and that data is authenticated. And then
Yeah, because that goes back
Yeah.
to that layered security approach, right? Like on the endpoint, let's configure this endpoint to its request, HTTPS or DNS over HTTPS.
Yep.
And then when our resolver that's internal goes to forward, let's have it do the same thing.
Yep. Yeah, and it uses the same port, obviously, as 443 as instead of 53 for DNS, which is nice too.
Yeah. It's also relatively easy to implement in the cloud as well, if you're into that. I don't know how many of our viewers are into the cloud, but I am.
Yeah.
Usually it's just a checkbox.
Yeah.
Yeah, when setting up DNS. So awesome. I think another good thing to point out is make sure you're using a reputable domain registrar
And DNS provider.
and DNS provider. Is, if you're going to some, really cheap, you're buying a domain for 50 cents, I would be a little worried. I'd be a little worried about that domain registrar. Can they get in? Can they, they get hacked and all of a sudden your domain is compromised and whoever can do whatever they want with your domain.
Yeah.
So I think that's another one to be careful about is protect your DNS like your bank, right? Is making sure you're using least privilege to make sure only the people who really need access to your DNS records and to your domain registration have it, right? The whole company should not have access to your DNS, right? So that's something that's really important to make sure that, your DNS server, your logins, you're using MFA and you're using least privilege.
What I'm hearing is we need another webcast with you guys. Is that what we're hearing here?
Yeah, because I think that we've done a decent job of like outlining some of the attacks and the remediation and everything like that. But I think kind of a deep dive into some of these, like more the security stuff would be really good.
Yeah. I mean, DNS is so foundational to the way that the entire world operates. Like, and I feel comfortable saying that the entire world operates. And it's a really cool attack vector.
Yeah.
Because people take it for granted.
He's encouraging it now. It's like,
Cool.
It is.
He's like
Yeah.
a super
really
villain,
cool.
this guy. We're not even going to get into his pranks, okay? That's for the next webcast.
Yeah, I mean, you just have like your regular boring brute force or DDoS or whatever. Who's thinking about DNS?
Yeah.
Yep. Yeah, and it's like Josh said, it's foundational, which is, and there's just it's got a huge attack surface. Yeah, which is great.
Yeah, a lot of these old technologies that are very early implemented in the internet are not built securely because they weren't thinking about that.
Back in the old days.
Back in
Greg.
the old days.
Back when we were young
Sorry.
whippersnappers.
Before 2015.
Sorry. Yeah.
Okay, I just want to ask the audience, are you noticing the evil grins these three have as they're talking about the attack vector, the like salivating? It's kind of creepy.
Yeah. Like,
Okay.
I mean, yeah, just to kind of paint a broader, darker picture. So
Again!
Darker.
Rachel's done a great job of like outlining some of the larger attacks, but there are some subtle, brilliant attacks that are done with DNS that are fantastic. They are just, yeah, they're just do DNS security or just DNS crazy attacks and just in a search, and you'll find all kinds of like super interesting things.
Yeah, like that PowerShell one with the macros and Word. I mean, that's so clever. It's so very niche
is.
and a very, very targeted attack, but it's cool.
Oh, it is.
It's
very
cool.
I mean, command and control over DNS.
Yeah.
Yes.
Let's go.
That
Okay,
is-
Kelly, I smell a podcast
Well,
right
yeah.
here.
Yeah,
right
absolutely. We have one final question if you all would like it.
Sure.
All right. We have a public DNS server, but tend to get hundreds of XDR flags from questionable domains. Anything to be concerned or just more block and move on? Kevin B.
Yeah, I have a lot of questions. First, why is it public? I mean, like I said, you have to have a really good reason for it to be public. If it has to be public, are you serving a small subset of people? Are you blocking, regions, countries that don't need access? I mean, it's hard when you start going into the your block listing IPs, because IPs, like I said, are very easily spoofed, right? So you get an attack from an IP and you just block it. Well, it's just going to come back with a different IP because IPs are just so easy to cycle through. This one's a little bit. This one's a little bit difficult. I think maybe you've got a couple of options when it comes to XDR, and if it has automated response, if it's just detecting, there's not a lot you can do. But if it's protecting and doing some automated response, then you can look for certain types of traffic and certain types of response and then block based on that. So if you're only expecting certain types of responses, then that's easy, right? You just block anything other than that. Would you add anything?
I don't have enough expertise, domain knowledge here operating like infrastructure as a service provider like DNS. Mm-hmm. So I don't have enough here to really add to that one.
Yeah, that one's just, I think XDR tuning is the biggest thing I can say there.
That's a serving public requests open on the internet for something as wide as DNS that's a whole big thing that
I mean, public requests in general are a whole rabbit hole you can go down, and that's why you have providers like Cloudflare that handle those sort of things for you.
Yeah.
Yep.
Okay, thank you guys for joining us. This has been a fun one. I like it. Yeah. Okay.
DNS is cool.
It is.
For PDQ, I'm Tara.
And there's a bunch of other people out there.
Hello, bye.
Yes, let's go. Hey, thanks for joining our webcast today. If you liked today's webcast or have been frightened by it, like and subscribe to our YouTube channel and leave us your comments. We would absolutely love that. And continue the conversation over on our PDQ Discord server. Thanks again for joining us, and we'll see you back here next week.